Hello students, today we are going to discuss a problem of quadratic equation which was asked in 2021 JEE Mains exam. So the question here is the number of pairs a comma b of a real number such that whenever alpha is a root of equation x square plus ax plus b equals to 0, alpha square minus 2 is also a root of this equation. Then we have to find the number of pairs a and b. So question says that if this equation has roots alpha and beta, let's say two roots are alpha and beta. So if one root is alpha, then beta will be alpha square minus 2. So if one root is alpha, the other root will be alpha square minus 2. Then we have to find how many pairs of such a and b are possible. So we will see that how to proceed this question. This is very interesting question. You will know a lot of new things with this the help of this question. Okay, so there are two cases. The first one is, let us assume that alpha and beta are equal, and in other case we will assume that alpha and beta are not equal. So for the first case we have assumed that let alpha is equals to beta. So if alpha and beta are equal, it means alpha will be equals to beta is alpha square minus 2. It means alpha will be equals to alpha square minus 2. On solving this equation, we will get that alpha equals to 2 and minus 1. So we will get the value of alpha, that is 2 and minus 1. And we have assumed that in this case alpha is equals to beta. So the beta will be also 2 comma minus 1. So what we get, alpha comma beta is 2 comma 2 or minus 1 comma minus 1, because alpha and beta are equal. So alpha comma beta will be 2 2 and minus 1 minus 1. Now we have to find the value of a comma b. So we know that alpha plus beta will be minus a, sum of roots, and multiplication of roots will be b. So from here we will get the value of a, that is minus alpha plus beta, and b will be alpha into beta. So from first case that says alpha comma beta is 2 comma 2, we will get the value of a, that is minus alpha plus beta minus 4, and b alpha into beta, that will be 4, because alpha and beta are 2 comma 2. So first answer is a comma b is minus 4 comma 4. If we move on to second case, which says alpha comma beta is minus 1 comma minus 1, so put the values here and you will get the values of a and b, that will be 2 comma minus 1. So from the first case, in which we have assumed that alpha and beta are equal, we get two pairs of a and b. First one is minus 1 4 comma minus 4, and second one is 2 comma 1. Now we will move on to interesting part of this question. The first part was very simple. In that alpha and beta, we have assumed alpha and beta are equal. Now moving on to other parts. Let's say if alpha and beta are not equal. For other cases, I have assumed that alpha is not equal to beta. If alpha and beta are not equal, then what cases arises? What can happen with this question? So if alpha and beta are not equal, it means, let's say if one root is alpha, so maybe that alpha is already equals to alpha square minus 2, and beta is equals to beta square minus 2. Question says that if one root is alpha, then other root is, if one root is alpha, then alpha square minus 2 is also a root. So maybe there is a possibility that alpha and alpha square minus 2 are also equal, and same goes for beta. If one root is beta, then other root, if one root is beta and beta is equals to beta square minus 2. So in this case, if beta is a root, beta square minus 2 is equals to beta, then beta square minus 2 will also be a root. And same goes here. If alpha is a root and alpha square minus 2 is equal, then if alpha is a root, then alpha square will also become a root. So first case arises if alpha is equals to alpha square minus 2 and beta is equals to beta square minus 2. So by solving this equation, we will get same quadratic equation, same as goes here. So we can say that alpha will be 2 comma minus 1. So from here we will get the same values. So 2 comma minus 1, we will get alpha 2 comma minus 1, and beta will also be 2 comma minus 1. So what will be pairs alpha comma beta? So there will be four pairs. Just like alpha, we have got two values of alpha, and two values of beta. But in second case, we have assumed that alpha and beta are not equal. Therefore, the pairs alpha comma beta will be 2 comma minus 1 and minus 1 comma 2. So we will pair that 2 with minus 1 and minus 1 with 2. So alpha comma beta will be 2 comma minus 1 and minus 1 comma 2. As you can see that if alpha is 2, then alpha square minus 2 will also be a root, because that will also be 2. And if beta is minus 1, then beta square minus 2 will also be a root, because beta square minus 2 is also minus 1. So from here, what will be the values of a and b? So a is minus alpha plus beta and b is alpha into beta. So from this pair and this pair, we will get the same result, minus 1 comma 2 minus 1 comma 2. So from this case, from second case, we got only one answer, minus 1 comma 2. Now we have three answers of a comma b, first, second and third. Now, moving on to other case. So we have discussed till now two cases. First case says that if alpha is equals to beta. In second case, we have assumed that alpha and beta are not equal, but alpha is itself equals to alpha square minus 2 and beta is itself equals to beta square minus 2. From there, we got this answer. Now, moving on to third case. Let's say alpha and beta are two roots, but in this scenario, alpha is beta square minus 2. Alpha can be equals to beta square minus 2, and let's say beta is equals to alpha square minus 2. Let's say 2 comma 3 are root. So maybe 3 is 2 comma 3 are root, then 3 square minus 2 is equals to this, and 2 square minus 2 is equals to this. Obviously these are not numbers, but we have assumed that. So alpha comma beta are roots. Let's say alpha square minus 2 is equals to beta and beta square minus 2 is equals to alpha. And in this case, this property is also satisfied. So we will, in third case, we will assume that alpha square minus 2 is equals to beta and beta square minus 2 is equals to alpha. Let's say what we will get from here. So in this case, so let's subtract these two equations. If we subtract these two equations, alpha minus 2 will be alpha minus beta will be equals to beta square minus alpha square. A plus, use identity of a plus b, a minus b. Cancel out alpha minus beta, because alpha is not equals to beta, so we can cancel this. From here we get alpha plus beta equals to 1. For finding a comma b, I need alpha plus beta and alpha into beta. So alpha plus beta is minus 1. Now I need the value of alpha into beta. For that, I will add these two equations. If I add these two equations, I get this. Alpha plus beta is given minus 1. So alpha square plus beta square equals to 2, equals to 3. I need alpha into beta. So for that, I will square of this equation. I will take square on both sides of this equation. So alpha plus beta ka whole square, that is 1, equals to alpha square plus beta plus 2 alpha beta. And from here, I will get the value of alpha into beta, that is minus 1. And the values of a comma b will be a is minus alpha plus beta and b is alpha comma alpha into beta. So I will get a comma b 1 comma minus 1. So I get another pair of alpha comma beta from third case. Remember, I have not considered this case because whenever alpha is equals to beta, I have assumed it in first case already. Now the tricky part is, let's say some student can think of first, second and third case. The main case is fourth case, which many of the students will ignore. In fourth case, what will happen? Let's say alpha comma beta were roots. So there may be possibility alpha is equals to alpha square minus 2 and beta square minus 2 is also equals to alpha. So in fourth case, we will assume alpha equals to alpha square minus 2 equals to beta square minus 2. And beta and other root, second root, that is beta. So let's solve this and see what we get. So alpha is alpha square minus 2 and beta square minus 2 is also equals to alpha. In this case, the condition is also satisfied. So for solving this, I will solve these two equations. From here I will get alpha equals to plus minus beta, but alpha equals to beta I have already assumed it first case, so I will solve only for alpha equals to minus beta. Alpha is equals to minus beta. So moving forward, I can see that alpha equals to minus beta, and alpha is equals to beta square minus 2. Put the value of alpha equals to beta square minus 2. Solve the quadratic and you will get the value of beta 2 comma minus 1. As beta is 2 comma minus 1, then what will be the value of alpha? So if beta is minus 2, then alpha will be 2. If beta is 1, then alpha will be minus 1. So I can get the pairs alpha comma beta as, so alpha comma beta will be 2 comma minus 2 or minus 1 comma 1. So what will be the values of a and b from this case? So we can get a and b by putting the values of alpha comma beta here, and I get 0 comma minus 4 and 0 comma minus 1. So there are four cases. You can also assume a fifth case. Fifth case will be, let's say first root is alpha, second root is beta, beta is beta square minus 2, and beta is also alpha square minus 2. You can assume this case also, but if you solve this case, you will get the same answer as the fourth one, because fourth one and fifth one says the same thing, just we have changed just the variable. So if you solve with the help of fifth case, you will get the same result. So from here on, I get how many cases, how many pairs of a comma b I got. So first answer is, from first case, minus 4 comma 4, 2 comma 1, these two are same thing, so 3, 4, 5 and 6. So the number of pairs of a comma b is 6. That was very, this was very interesting question was asked in JEE Main 2021, but I think this is a advanced level question. Sometimes in mains there are difficult questions of mathematics, and this question is one of those questions. I hope you understand this, you understood the solution till then. Okay, tata, bye bye.